All right, guys, I'm going to start to catch up to you. So this one I'm just taking one woman, so there's nothing to adjust. I just use exactly what they tell me. 2.9. Here's my 3. I want this area there. I make a z-score out of that. I'll make a z-score. And then divide by the spread they give me, because I do have an individual, so I can use that spread. And I don't know, what do you guys do? You get 0.32. Yeah. And then when you look that up, the nice thing with doing this kind of problem over and over again is you've got to understand the basic problem before you can really understand the tweaks that we're going to do. Whenever you look up a z-score, it tells you the area below. Where did I put those there? So 0.32. I saw most of you guys got this 0.6255. So that goes here. Just make that a habit. The minute you look up the z-score, put it below what you just looked up. And then go, did I answer the question? Ah, no, shit. So 1 minus that, 3745. So I saw most everybody getting that. This is the one where two things happened. Took a sample, asked about the sample mean. So the very first thing I should do is change that spread. So 0.31 divided by square root of 38. And I saw some people do this, which is what I said to do at least, and then some other people went one more place, and it's up to you. But the funny thing is, one way leads to a z-score of 1.99 and the other one leads to 2. So what I normally do is I just calculate it both ways. So I'm ready with my key for whatever the hell you do, right? So if you got a z-score of 2, you're fine. If you got a z-score 1.99, that means you were a little more precise with your spread. Either thing you do, whoops, sorry. This would be 0.9772 one way. So some of you guys got 0.0228. And I think when you look it up with 1.99, it's 0.976 something. 1.99? 9761? You guys kind of with me? Is everybody with me? So you did it one way or the other. So either you got a z-score of 2, and you got this answer. Is that cool? Is that all right? All right. All right. I can't try to guess what the question is in your head. Some of you guys look like you have a question, but you're not telling me. So, or you did z-score this because you got a more accurate, a little more spread out standard deviation. So that would lead to an answer of 0.0239. So I would accept either one of these. Okay, maybe. It all just had to do with how much you rounded your standard deviation. That's it. Okay. Maybe. So number 2, you start to realize I like to do this. I like to have the first part of a problem be old news, and the second part be where things change. So why do I know I can do the first part of this? Yeah, it's normally distributed. I don't need any sample size. Any sample size is good. I don't need something to save me. So this kind of problem, I've got to make 2 z-scores. Where'd they go? 80.2. Yeah, it's actually gone down. I think I told you guys that. It's been a rough kind of few years for America. So 80.2, and then I've got 75, and I've got 83, and I've got to make z-scores out of those. Is this? We did a couple of that, like the time to park problem on the handout yesterday. So to cut to the chase, 75. I get negative 0.35. So you got z-score for 75. And then for 83, I get 0.19. I like it. And then of course you look up the areas, you subtract them so you can get the area in the middle. 0.19 has an area of 0.5753. And negative 0.35 has an area of 0.35, 3632. So when you subtract those, what do you get? 2121? Yeah. Neato. Is that what you guys got?
Yeah.
2121, I like it. Forever 21. Okay. So, and then, and same way with this, right? The nice thing with this one is there's just one data point, so I only have one thing to change. So this is probably somebody who lives longer than 120 years. I can't remember right now. I think the oldest living person right now is in their 100-teens, 118 or something like that. So what is the probability somebody lives more than 120 years? By the way, do you notice how this is actually true data? Or at least this was like a couple years ago, I think. So then you make a z-score. And let's see. Get 2.67. Look up 2.67. You get 9962, it looks like. So then this would be 0.0038. So like a 0.4% chance that somebody born in 2004 lives to be 80.2. Or I'm sorry, lives to be 120. What changes on this one? Standard deviation. So the first thing I got to do is figure out the new standard deviation. So 14.9 divided by square root of 37. For some reason, I always get people put all kinds of weird shit in here. You gotta identify with the correct symbols what the numbers are that I give you. This is never gonna be like 11.8. It's never gonna be a decimal, because what is it? It's n, and n is the number of things. So it can't be 11.8. And here I get 2.450. Is that cool? 2.450. Man, you guys, I'm sorry. You guys look so oppressed right now. I'm sorry. You signed up for it. All right. Just clear your mind. So now this is going to kind of suck. I got my 2. I'm interested in it. See how it's the same question as this. Now I'm just asking what's the sample mean chances to be in there. Do you notice, real quick, I can make a prediction here. Isn't this like the middle? The 75 to 83 is sort of like the middle in a sense, right? And what happens when I take samples? They all come towards the middle. So the answer I get on this problem should be a lot bigger than this, because people are rushing to the middle. I should catch more in here then. This answer should be bigger than this one was. Do you have to know that really? No. So if I draw the picture, I've got my 80.2 there, I got my 75, I got my 83, got to make z-scores out of those. But now I got to use the correct spread. So see how it's the exact same, I didn't write that formula down, I suck. But it would be the exact same formula, you just got a different number there. So I get negative 212. And if I do it for 83, I get 1.14. Like it. Like, why do you sound like a question, Jeff? That's what you got. This is true. So this is 114, and this is negative 212. So I do exactly like I did before. See, every step after this is the same. Of course it is, because the basic idea doesn't change. It's just the only thing that changed was I got to use the right spread. After that, the idea is the same. So when I look up 114, I get 0.8729. When I look up negative 212, I get 0170. So what's going to be in here then? It's going to be 0.8559. Is that right? So this one only had 21% between those two. A group of 37 people, they have an 86% chance almost to have a life expectancy in between there. Of course it does, because they all are going to come towards the middle. So the middle is going to get bigger. There's going to be more shit in the middle. That only makes sense that number got bigger. Maybe. So to be honest, the real picture should look like this, but you know, it doesn't really matter. It's just a visual anchor. It doesn't have to be perfect. All right. I got one more idea for today to go through. Oh my God, Jeff. That's too bad. One more idea and then we'll head out. Oh, let me go ahead and give you the practice test before I forget. I could see me doing that. Just glance at this and then put it away. Well, it actually comes out to be 5%. In a perfect world, I would make it 0. I did that one semester, everybody died because nobody did the homework. And I understand that. As a human, I'm like, this ain't worth shit, so why would I do it? And then you're like, oh, it is worth something, because that's how I do well in a test, is to do freaking homework. So in a perfect world, people would understand that. But I know we're all human. If I got a class that the homework's worth 20%, yeah, I'm gonna do that shit. But it's funny how our brains are not looking at things right.
What if you find
But, huh?
Because what I find effective for me is I just do your worksheets over and over.
Okay.
Like your worksheets and then like practice tests, and I mean that worked out pretty great for me.
So the nice thing with homework being 5% is it can't kill you, it could hurt you. If you don't do any homework, believe it or not, 5% of your grade, it does take you down. It could easily change your letter grade, right? but it's not going to like destroy you. Am I? Yeah, good. I kind of want to be recording. Some of my colleagues make their homework worth 40% and they never look at it. So then students can fail every test and they have basically an A, 40% of an A, and they pass. And then they take me and I'm an asshole. I make people understand shit. It's wrong. Not all. No, come on. Not everybody, but you know there's some of you. Do you guys kind of get my reasoning there? So that's a good question, because the reason I do this psychologically is because if I say the homework is a part of this grade and is worth 20%, then you're more motivated to do it, when in reality you should just be motivated to do it, period. I don't care if I make it worth nothing. Right? You should be angry if I don't give you enough homework. Yes, you should be. I mean, but see, that's so counter to what you think. Because people see homework as something to check off. And I'm trying to get you guys to realize, every time I tell you about homework and I say, do what you can to get ready. And I'm going to have my own problems, but it's totally your thing. Do what you need to get ready. So if you really don't need to do shit on the homework and you feel like you're ready for a test, I'm not going to kill you for that. I mean, the 5% zero is going to affect your grade a little bit, but not kill you. So more power to you, whatever works.
Do you accept like?
Yeah.
I thought all the homework was due the final date of the
shit.
test. So I didn't do.
But it makes sense why I make it due the day of the test.
Yeah, no, totally.
Yeah. But yeah, you can turn in chapter 1 homework on the day of the final.
Oh.
It is very late.
Yeah.
It's not 4 weeks late. It's the entire semester late, right? So I know we're in 4 weeks, but that is 100% of the class. So you are 100% late. So you still get some points because the final's cumulative. I want you to have a reason to do it, but you're not going to get anywhere near full credit.
So I should just turn it into.
Just give it whenever. Yeah. Yes.
I think what makes it difficult for me to understand your tests and homework is you don't word the test like the book does, so that's what confuses some.
Exactly. And I never want a class to become something where everything you learn is one way. Because the idea behind what you do doesn't care how it's represented. Now, I know as a student, it would make it easier if everything was exactly worded the same way, but then that means that I never test if you understand an idea. I'm just testing if you understand a setup. That is not what classes should be about. And I get all kinds of shit about that, and I have never changed because I'm an asshole. No, because there's a method to my madness. Anyway, so some people understand that, and some people don't even care. They just do their work. I love it. Or some people think I suck. I don't, whatever. Okay, maybe. Is that all right? So yeah, I agree with you. I totally agree with you. And I actually like that happens. Not because I'm an asshole, but because the idea is independent of the wording or the setup. There's an idea. So you have got to try to get to the idea. That is what is hard as a student. And that's really what the tutors should do. So I've had a few people tell me some troubles with the tutors. When I was in charge of the center, I made it continuously the idea you're trying to get the concepts across to a student. So what I tell tutors, and what I tell you guys sometimes, I haven't said this yet, but a tutor's job is not to get you an A on anything. That is not their job. Their job is to get you to understand the ideas. It's up to you to apply them correctly then, right? You guys kind of with me? Like, my job is not to make anybody get an A. That can't be my job, because then I can make my job easy, give everybody an A, watch a movie every day, right? You know, like, yeah, sounds good. You guys kind of with, I'm sorry. Anyway, don't let me, I'm going to go off on a rant about the state performance funding and what does success mean and all this kind of bullshit, but it's crazy. Anyway. All right. Where was I? What was I doing before that?
Last concept. Another concept.
Oh yeah, I'm sorry. All right.
The last concept.
Last concept for today.
Just a reminder.
Last concept. There's 2 applications of it, but the last concept. All right. So let me. What I try to do with this, I try to build on what we know. So this, believe it or not, we're about to get into chapter 8. One thing I want you to realize: how many sections in chapter 6 do we do?
2.
How many sections in chapter 7?
2.
The chapter 7 sections were the central limit theorem stuff. So like, yeah, good. So we do 7.1 and 7.3. I like it. So chapter 7 was just that central limit theorem stuff. Change the standard deviation. You with me?
So on the test Tuesday, it's an 8.
Oh, hell yeah. Definitely.
Wait, what did you ask?
As we all know, because it's on the homework sheet, the next test goes up through chapter 8.
Oh, okay.
Through chapter 8, right? Including those 2 sections. 6 has 2 sections, 7 has 2 sections, 8 has 2 sections. So it sounds like a lot, but not really. 8 has 3 sections, that's right. We're going to do 2 today. Because they both have this one idea. Sorry. So, I'm not going to talk directly about the idea. I'm going to build up to it. Can somebody help me out? Somebody, let's see. This is something you should be able to do. I don't think we've done exactly this yet. Poor little black marker is dying. Can anybody tell me this is a normal curve. It's a little bit, it looks more like Jabba the Hutt, but can anybody figure out what 2 z-scores have 90% between them in a normal curve? They do the middle 90% of a normal distribution. Why is that a difficult question considering what the chart knows? And then you realize it's not that difficult. What's a chart understand? Areas that are where? Below a z-score, right? To the left of a z-score. I want these 2 z-scores, don't I? Let me ask you this. If this was -3, this would have to be because of symmetry, right? So this is like -z, this is z. So I just got to figure out what that z-score is that has 90% in the middle. The chart does not understand this shit at all. What number can I feed to the chart that it would understand? That would get me this. What's the only thing the chart understands? The area that is?
Left.
How much is outside of here? That's 90. How much is outside?
5.
5 on each side.
Okay.
10 total. So how much is on that side? 5. If you look at 0.05, you get the z-score. That's not a z-score. That's an area, right? So look up 0.05. What's that z-score?
Negative.
No.
No?
Areas can't be negative.
Oh, yeah.
The z-score will be negative, right? Yes. Yes. Let me make sure everybody else gets that. You're right. Just wait. You kind of... It's good. You're quick. But other people want to give a chance. Do you guys see how that's another asterisk situation? So... I'll need to move that around. 0.05 is right in between in these two. And that's our good old -1645 again. Is that cool? Okay. Real quick, watch this. I might as well just show you this right now. This is what I call a little baby chart. 90%, 1.645. I'll bring that back up in a minute. So between 1.645 and -1.64, between those two, there's 90% of the information in a normal curve. So for example, I know the average height of men is 69 inches. I know the standard deviation is 2.8, I think, if I remember correctly. I know that I'm basically right at the average height. Boom. My basketball dreams went down when I reached 15. I'm like, ah, shit. Between what 2 data points would I find 90% of heights of men? Well, we already know how far out I gotta go. How far out do I have to go? We already know. 1.645 steps, right? Let me make sure you guys are with me. Heights are normally distributed. I don't know if I said that before, but they are. I expect people to be close to the middle and very few out here. That's one reason why you call it normal curve. If everything is normal, height should be like this. So heights are normally distributed. I want to know between what 2 heights would I find 90% of all men? I already know, we already figured out right here how many steps to take. So what's this going to be? It's going to be 90 minus 1.645 steps. And this one's going to be 90 plus 1.645 steps. You guys with me? What does this represent? What does this work we've done? If I have a normal curve, if I go up 1.645 steps and down 1.645 steps, I caught 90% of the data. That's what this work meant. Now I have a specific normal curve. How do I get 90% of the data? I go up this many steps and down that many steps, and then I've got 90% of the heights are in there. Crowd goes, man. So, before you guys are all cranking this in the calculator, hopefully, a few of you guys are, but do you guys see, is it okay if I do this? Do you see that? 90, give or take. Right? So I can kind of consolidate this in one little phrase. Yes?
The answer that you get from that, is it going to be a Z-score, area, or percentile?
No.
None of them?
Nope.
So what is it?
What does this represent again? Inches tall, the heights of men. So this is going to be two heights. Between these two heights live 90% of all, well, this is American men, by the way. I should make that distinction. I like it. So, what do you guys, anybody, what, real quick, if I do it like this, what is 1.645 times 2.8? You get 4.606, right? So look how this is really, really nice. 90, where am I getting 90 from, Jeff?
That's what I was thinking.
All right, everybody should have been yelling at me. I love you
That's why I was
guys.
confused.
I love you guys. It's 69, right? That's the mean.
Okay, that makes more sense.
Then say that. Thank God I'm not one of those teachers that are all like, you've had those math teachers like, I don't make mistakes. I'm like, I make some freaking mistakes. Holy shit, help me out. So I'm sorry, I didn't mean to make that complicated. That's
Okay,
my
that
fault.
makes-
All of a sudden I looked at him like, 90 inches tall, Jeff? All right. It's my bad.
Yeah, it's because I was confusing because it was like 90%.
I'm with,
and
that's
the-
what my brain did. Is
Yeah.
So then, yeah, just tell me. All right, everybody cool with that?
Yeah.
All right. So 69 inches, give or take that much. Right? So if you go down, it becomes 64.394 and 73.606, I think. If I did that right, man, I don't trust my brain now. So 90% of all individual men, 90% of all men would be between these two heights, right? So for example, this is 5'4" or something, and this would be 6'1" something. You guys with me? 60 inches is 5 feet, 72 inches is 6 feet. Okay, maybe. So, let's bring in what we just learned today, and this is going to be what Chapter 8 really is, and this is why Chapter 8 is after Chapter 7. I normally am not talking about individuals. I am normally talking about groups. This doesn't give a shit what's going on. How many steps, how many standard deviations do I go away from the mean to catch 90%? 1.645 up and down. Doesn't matter about any specifics. That is the truth. So if I do this and I say, what, between what heights would I find the middle 90% of groups of 40 men? So if I take a random group of 40 men, between what two heights would I find 90% of all the averages? Okay, that's a weird question, but There's only one thing that changes on the work I did. We already know what that one thing is. What changes?
Standard deviation.
Yeah. So now instead of being 69 plus or minus 1.645 times 2.8, it's divided by times 2.8 divided by square root of 40. Because again, when I take a sample and I ask about, put average in there. Take a sample, ask about the averages, what changes? The spread. So now, over here, I took 1.645 steps above and below the mean. Boop. What happens when I take a sample and I talk about the sample means? The spread changes, the step size changes. Yes?
Where did the 40 come from? Is that what I'm
Well, I didn't write it. Oh, there it is.
not? Oh.
A group of 40 men. Why is, yeah, this is for men, that's right. Here we go. And so, help me out. This will be 69, give or take, whatever this is. It's roughly 0.7. I don't know. Yeah, 0.728.
Yeah.
So then that becomes, if I subtract it, real quick, it's pretty cool. There's no plus or minus button on your calculator, right? This is plus and minus. Okay. So it's just a minus this would be 68.272, plus that would be 69.728. So 90% of all groups of 40 men will have an average height between these two. I really want you to see, is that bigger or smaller of an interval than what we got for individual men? That is much smaller. Why does that jive with what we were talking earlier? When I take groups, they get closer to the real average. They can't get so far away. One dude that's 7 foot tall, not gonna freak out. 40 dude, oh, I'm gonna freak this shit out. Right? So it should be much closer to the average. Okay. Okay, now, we still haven't quite gotten to chapter 8 yet, believe it or not. But I like starting here. This is all stuff I could have asked you based on what we did through chapter 7. There's nothing new up here, really. So here's the new thing. Okay. So everybody got all this?
What does it say? Reward?
Yeah.
Here? 90% of averages of groups of 40 men.